we look at a problem from 1987. Yes, that's right, that's way back. But it's kind of interesting problem on complex numbers, so let's look at that. For this equation for complex number z, where n is a natural number, we want to prove that it has roots with modulus 1 if and only if n plus 2 is multiple of 6. In this problem, we want to prove this equation has solution with modulus 1 if and only if n plus 2 is a multiple of 6. And of course here is natural number. Now let's look at the only if part. So let's say assume z modulus is 1. So let's look at the original equation. We can rewrite it as zn and z minus 1 equal 0. This is nothing but rewrite the first two terms here, right? Since the modulus of z is 1, what we can do is to further rewrite it equal to 1. Now take modulus on both sides. What do you have? The modulus of z equal to 1. Now this term here, the modulus would be 1. You take the modulus here and the modulus of z minus 1 is equal to 1. So the first term equal to 1, this is equal to 1. So we must have z minus 1, the modulus is also 1. Here comes the geometric interpretation of complex number. So in complex plane, when we say z has modulus 1, we know that it is on this unit circle here. And the modulus of z minus 1, so which means the modulus is also equal to 1. So that is, z must be somewhere here. So if this is z, and this would be z minus 1. What we're saying that the length of this is also 1. That is, you're going to have, this is a regular triangle here, so this must be 60 degrees. Of course, there's another one, which is the other side of here. So this is another z, another possibility. So what is the value of z here? That's equal di pi over 3. And this one is equal I negative pi over 3. So from the condition that the modulus of z and the modulus of z minus 1 both equal to 1, we make a conclusion that z has to be one of these two values here. Z must equal e positive or minus I pi over 3. So that is the sixth root of unity. That is z to the sixth power would equal to 1. And z to the third power is actually equal negative 1. So what is the equation earlier? So this equation here, let's rewrite it. So it is zn and z minus 1 equal to 1. Now we know z is here. Z minus 1 is nothing but another sixth root of unity here. If this is z here, z minus 1 would come here, right? So this is 120 degrees here, right? This also, similarly, this one minus 1 would bring z to here. So this is z minus 1. Okay, let's call this z lot and z1. Z minus 1 is equal z squared. All right, so why that is the case? What you can do is you can start from here. Z to the third plus 1 equal to 0, and then you factor it. So from here we know that b is not negative 1. So for this z lot and z1, we both satisfy this equation here. So this quantity equal to 0. That is z squared would equal z minus 1. Okay, so which means z to the m plus 2 equal to 1, right? Because z minus 1 is z squared. Z squared times z to the n, so we have this. So we know z is roots of unity here. So which means n plus 2 must be a multiple of 6. So we have the proof, right? So from the property that the modulus equal to 1, z minus 1 must equal to 1, we conclude that z must be either this positive 60 degree or negative 60 degree here, right? This is the roots of unity. We also conclude that the n plus 2 must equal to 1, that is n plus 2 is multiple of 6. Now on the other hand, if we know 6 divides n plus 2, what we can simply do is just plug in the number that we know into the equation, right? So if we plug in this and use the fact that this value to the 6th power equal to 1, we can verify that is indeed a solution and that has a modulus of 1, right? So that's the easy part I'm going to skip.
Hope you enjoyed the video. For these and other interesting math or computer science topics, please like, share, and subscribe to the channel.